That's how we start the video too. That quote.
I'm loading.
All right. So let's talk about the final exam. So I'll go through things that I think might be on there, and then if you have questions along the way, I can give you some examples or recover some aspect or something like that. So, but let's start. Final exam. So 10 questions. Very, very similar to the midterm. Exam is going to be designed to take about an hour. So normal length exam. It's not going to be like a super double exam or anything. So it's going to be designed to take about an hour. You have the full 2 hours to take it. Our exam is, what, Tuesday?
Yeah. Be like same time.
Tuesday at 10:10 a.m. All right, and that'll go until noon. So you have the full time to take it. You should not need the entire time, but if you'd like it, you have it. Okay. 10 questions, 10 points apiece. Very, very similar to the original exam. There will be plenty of programming on it. So expect that you will have to write probably at least 3 methods and then probably 2 additional code examples of some type, maybe, define an array and fill it with something, that kind of stuff, some logic stuff. You might also, then additional questions, I might give you some code, say, what does this code do? And you should be able to tell me what that code does. And like I've said before, I'm not looking for you to give me a line by line, this line defines a variable, this line does this. I mean, you can do that if you want, but I want you to tell me as a whole, what does that code accomplish? Okay, because I'm probably writing 5 or 6 or 7 lines of code to accomplish some task. And in the end, I want you to tell me, ultimately this code counts from 1 to 10 and only displays powers of 3 or something like that, that kind of thing. All right, so questions about the format of the exam? All right, so remember my policy that if you do better on the final than you did on the midterm, I'll replace your midterm exam grade with your final exam grade. So for those of you who did poorly or didn't do as well as you would have liked on the midterm, you can fix that by doing better than that on the final. It's not like an average thing. I just replace the grade if it's better, but not the other way around. So if you did well in the midterm, you can't just ride that into the final and say, well, I got a 92 in the midterm and I got a -7 on the final. So I'll just take the 92 and walk. It doesn't work that way. Okay, so you can only improve an old grade. You can't ride an old grade into a better new one. All right, so let's go through the stuff we've covered up to this point. The exam will focus more on the things that we've done since the midterm, but stuff prior to the midterm will be on there as well. It is cumulative. There may be some Android stuff in there, but the programming things themselves will mostly be just Java logic as opposed to Android-based logic. That just kind of is, it's easier to ask those questions. And also considering the goals of the class, the goals of this class is to become a proficient programmer. We'll be using Android the entire semester, next semester in 300, but we're going to be looking at data structures, stacks and queues and linked lists and binary trees and all sorts of stuff like that, and exploring them through writing apps to get you that experience. So the app side of things, it's not a class about Android, it's a class about programming, specifically data structures next semester, it's just kind of more fun to do it through writing some apps, and it gives you a viable skill for internships as well as making some money if you want to put stuff on the App Store and future employment. So it's a valuable skill that you might as well get by accident while you're also learning the programming stuff. But the class is a programming class, not an Android class. That makes sense? Same thing's true in this class. So even though we've done some Android stuff, and it would be possible that I could ask some Android question about like activities or something like that if I was looking for a filler question, but stuff dealing with programming, I'm looking for your ability to write logic, create algorithms, write methods that do things. I really like string manipulation type problems or array manipulation type problems. So those would be two kind of generalistic areas that you might want to look at, because those tend to be questions that are easier to come up with on exams that make something algorithmically difficult enough for an exam, but not overly complex. So reverse a string, remove the vowels, stuff like that tend to be good go-to moves on an exam, or take an array of integers and if it's a even number, multiply it by 7. If it's an odd number, multiply it by 4, something like that. Just some kind of manipulation of collection data structures tend to be questions I've historically asked often. All right. Also creating objects. So be able, if I say we want to create an object that is representative of a, like a dice object where we have like a number of sides and it should have a roll method or something, you should be able to, or like a patient record object where a patient record has a first name, a last name, and an age. You should be able to create a simple Java object that stores those 3 fields and then has an appropriate constructor, that kind of stuff. Okay, so that's more high level programming stuff. I'll fill in more stuff as we kind of go through here. Okay, so obviously, this is something I talk about often, right? This whole, I always come back to this idea of how do human beings solve problems to keep us in touch with why we're learning to program. What's the purpose of that? I won't ask you this question just outright. It won't be like a generic, what are the 3 ways human beings solve problems, or what's the mapping? So we're past that at this point, but you should never forget that because it's kind of the core of why we program and why programming languages work the way they work. Same thing, history of our languages, important stuff, but this is really 200 material. I'm not going to ask you about this. Still should know it, but if you're looking at studying for the exam and refreshing your skills, you don't have to worry about, which came first, Java or C# and that kind of stuff. It's not going to be part of the exam. 3 kinds of programming languages. If a question like this snuck on there, it might fall into one of these categories. The whole idea of a low-level language versus a high-level language. Pretty unlikely. I would think I would be needing to find like an extra question, like maybe I have 9 good questions and I feel like we're kind of sitting near an hour of work at this point. So I kind of need like a quickie, like a question that's either it or you leave it blank type of thing. So I could ask something about that, low level versus high level. Guaranteed there'll be at least one number conversion question on the exam. Convert binary to octal or hexadecimal to decimal or something like that. If you ever have an exam with me where I don't have at least one question like that, I forgot it. So that's something that you should know how to do, and those should be free points. And it's a invaluable skill when you, even just think about the hackathon a couple weeks ago where, even though what we were doing had very little to do with binary and things like that in general, just that idea of, I have to convert my inputs into something else because representing them in binary made some sense. And then even from binary, I took it to another level for representing the data. So being comfortable with various number bases, even just from a data representation perspective, is a pretty important skill. And then if you get into the 325 class or systems programming and stuff like that, You start the deeper you get into the underlying hardware of your computer, the further you move away from decimal, and the more you start seeing hex and binary. Is the kind of the punchline. Plus, it's fun. We enjoy conversion questions, right? Oh yeah. That's not a conversion question. Merge sort will be on the exam. It's question number 2. Write merge sort. And then I'll have the anti-merge sort tip jar up here. Write merge sort or contribute to the fund.
The more there is, the more it gets written on the board.
There will not be merge sort on the exam. Like I said, you'll have merge sort next semester, and you're going to laugh at how hard you thought it was. One day you're going to find merge sort not that hard. I promise you. Okay, so a question like this, I'll call it a 10% chance, might find its way onto the exam in some form. So definitely understand that the languages we use today are high-level languages, and humans like those. And low-level languages is what we look at in 325, the computer organization class, the architecture class. That's the one-to-one relationship with a CPU. And then we all love the zeros and ones, but maybe don't want to do that on a daily basis. So this could find in a desperation situation, this could sneak onto the exam. But frankly, if I was that desperate, I might just put another conversion question on there. Really like those. Just love conversion questions. Pretty much the same argument for this slide versus this one. Fair game, but low, really low chance. Same thing. So these 3 slides are really important for kind of pigeonholing what kind of language you're dealing with. Oh, did we die?
Yeah.
It just made into
Good job.
Did it?
Yeah, slowly. It's looking slightly red. Let's make a little.
It's like it's not even on anymore.
It was working so well before.
Now we got
Right, merge sort or fix the TV.